Hello friends, this is Mr. Volcano and we'll be having our second week of a maths e-learning class. Hope you had fun over the weekend. I'm sure you enjoyed yourself and you had fun. Remember, it's still time to stay indoors, wash your hands regularly, sanitize yourself and avoid close contact with people. Now, said before us like we did last week, where are the class rules? Now, we did the class rules last week. Every week we're going to be talking about the class rules. So remember to update it, write it somewhere. Keep it written so that you won't forget, because you're going to be using them in all our classes. The class rules. Now let's see something about the quote of the day today. Can you read it to yourself? There is only one way to solve problems in life. It is by the application of math. There is only one way to solve problems in life. It is by application of mathematics. Let's have a little fun.
Brain tofu. What's a rational number?
Exactamente.
It's a type of number used in mathematics. Rational. In this episode, we will explain some definitions in mathematics. We will look at natural numbers or counting numbers, whole numbers, odd numbers, even numbers, integers, negative integers, rational numbers, and irrational numbers. So if you're not sure about one of these terms, you should pay special attention. The first definition is natural numbers, which are also known as counting numbers. Natural numbers go from 1 to infinity. 1, 2, 3, 4, 5, 6, 7, 8, and so on, and so on, as far as you can count. Infinity? That's right. Natural numbers go on forever and ever. We can never know the largest number because we can never get to the end of it. It keeps growing and growing. The next definition on our list is whole numbers. Whole numbers include all the natural numbers plus one very important number, and that would be 0. The next definition is for odd numbers. Odd numbers are the whole numbers that are not divisible by 2. These include 1, 3, 5, 7, 9, 11, 13, and so on. 2 does not divide neatly into any of these numbers. There will always be a remainder left over. Even numbers, on the other hand, are defined as the whole numbers that are divisible by 2. 0, 2, 4, 6, 8, and so on. 0? Yes, 0 is included because any number ending in 0 is divisible by 2. Numbers like 10, 20, 30, 40, and 50 all end in 0, so they are divisible by 2. In fact, any number that ends in 0, 2, 4, 6, or 8 is divisible by 2, no matter how big the number is. All you need to know is the last number. If the last number is divisible by 2, then you know 2 goes into the entire number. Alright. Moving on to the next definition on our list, we have integers. Integers are all the whole numbers and all their opposites. This means all the positive numbers and all the negative numbers. The opposite of 1 is negative 1. The opposite of 2 is negative 2, and so on. All the whole numbers greater than 0 are positive integers, and all the whole numbers less than 0 are negative integers. 0? Yes, 0 is neither negative nor positive, but it is still an integer. Next on our list are rational numbers. Rational numbers are any numbers that can be written as a ratio. This means we can write it in the form A over B. A can be any number, and B can be any number. They include negative numbers, repeating decimals, and terminating decimals. These can all be written as a ratio of one number over another number. Last on our list are irrational numbers. Irrational numbers are numbers that cannot be written in the form of a ratio, A over B. Irrational numbers include some square roots, like the square root of 2, the square root of 3,
10 billion digits,
and the square root of 99. Other irrational numbers are pi, Euler's number, and the golden ratio. In all of these cases, the numbers do not terminate. They go on forever and ever. This makes it impossible to write them as a ratio, A over B. So we call them irrational.
irrational. Now I get it.
Let's review the math terms we learned. There were natural numbers, or counting numbers, whole numbers, odd numbers, even numbers, integers, negative integers, rational numbers, and irrational numbers. Math is an awesome subject to study. Oh, totally.
I'm sure you had fun in learning of the numbers we learned just now. It's about the icebreakers, but the icebreaker today is just centered about knowing different types of numbers. Now let's go to the topic of the day. Fractions. Can you say it to yourself? Fractions. Last week we did revision on fractions. Today we are moving into fractions properly. And today we are learning to solve ordering of fractions, and we're learning to solve equivalent fractions. Now let's pick it one after the other and see what you're trying to do. We're learning to solve ordering of fractions, and we're learning to solve equivalent fractions. Said before is what we call the keywords. Now today we are adding 2 more words to the keywords we had last week, same and equal, so that we can be able to understand what we are doing. Now there are 3 types of a fraction. Can you name them? If yes, then let's mention them together. Let's mention it together. Now remember. Okay, let's do. Number 1, proper fraction. Number 2, improper fraction. Number 3, mixed number. Can you repeat it? Proper fraction. Number 2, improper fraction. Number 3, mixed number. Now let's move up a bit and try to see what's about the topic for us. Thanks for watching the video. I'm sure you had fun watching it. Now let's see, what are equivalent fractions? Equal, same. Those are the keywords for equivalent fractions. Fractions that are the same. They are fractions that have the same number, either on the numerator part or the denominator part. Now, the numerator and the denominator must be multiplied by the same not zero number, that's whole number, to have equivalent fractions. So now let's see some things, examples of equivalent fractions. Let's see how it is. 1 over 2, 2 over 4, 3 over 6, 4 over 8, 5 over 10. Now how do we get to see that? 1 times 1 gives you 1, 2 times 1 gives you 2. 1 times 2 gives you 2. 2 times 2 gives you 4. 1 times 3 gives you 3. 2 times 3 gives you 6. Then you continue like that. You can continue. Now, when you multiply with the same number up and down, we call it equivalent fractions. Now, let's see. Equivalent fractions are fractions that represent the same amount. They might appear to be different, but they represent the same amount. Now, what do we now call ordering of fractions? Arranging of fractions in ascending or descending order. Now, this is ascending. You increase from smallest to the largest. We call it ascending order. Now, ordering of number can be with the same denominator. If you see from the example, arrange 3 over 7, 2 over 7, 5 over 7, 1 over 7 in ascending order. You see, of course, 1 is less than 2 is less than 3 is less than 4. Then we're going to have 1 over 7 is less than 2 over 7 is less than 3 over 7 and is less than 5 over 7. So that's the arrangement when they have the same denominator. Now, having the same numerator. Now, if they have the same numerator, now it's a different format than when they have the same denominator. Now, it says, now look at you. When the fraction have the same numerator, the fraction with the highest denominator is the smallest. That means the bigger the denominator, if the numbers up are the same, the bigger the denominator, the smaller the fraction. Now that means the numerator is 3 in all of these examples. So the 3 over 4 is the biggest, where 3 over 8 is the smallest. Now we have an example, a worksheet on the screen. I have a worksheet on the screen that has been done for you. Yours is to just pick up your, print out this page, pick up your marker and color the equivalent fractions of the different sections. You can see this 1 over 3 is the same thing as 3 over 9. 2 over 4 is the same thing as what over 8. You solve that out. 1 over 2 is the same thing as 5 over 10. 1 over 6 is the same thing as 2 over 12. 6 over 9 is the same thing as 2 over 3. 2 over 10 is the same thing as 1 over 5. 1 over 4 is the same thing as 3 over 12. 2 over 3 is the same thing as 8 over 12. And 3 over 5 is the same thing as 6 over 10. Now at the end of the lesson, what have we learned? What have we been able to do? I can identify equivalent fractions when I see them at the end of the lesson. I can identify them. I can solve ordering of fractions either in ascending order, that's from the biggest to the smallest to the biggest, or in descending order, from the biggest to the smallest. Now, this class presentation was produced by Mr. Volcano, like you all know him, for Tender Years Preparatory School. Now you can check through the resources and try to see what things we used for the class. Thanks for watching. I love you so much. See you next time.